In this lab, you're going to be looking at a system in equilibrium and applying a few different stresses on that system. You're going to be looking at some pictures that show you the observations, what you would see if you're looking at the system. You'll record that information and then explain why you're seeing what you're seeing. So I'll go through an example that's also in the slides written out, and I'll walk you through all the parts of the lab, starting with where you're supposed to start, the background right here. So you have hydrogen gas with iodine vapor, and that forms hydrogen iodide. But this is a reversible reaction, so that means that hydrogen iodide can break down, it can decompose into hydrogen gas and iodine gas. So you already know that you can represent a reversible reaction with that two-way arrow. So you should already be familiar with that. Onto the pre-lab. So here, these questions, just 1 and 2, are what you're going to be recording on a piece of paper for yourself. I don't need to see these answers. I have the answers provided for you already on the next slide, so you can check your work so that you know what you're doing before you go into the actual experiment. So for this second one, it's very similar to what you're going to see in the experiment. You have a reaction. This reversible reaction is in equilibrium. And then it gives you some information. It says the test tube on the left here, this blue color, tells you what this copper solution would look like. So what the left side looks like if you're going to the left, right? So what your reactants would look like, a blue color. Then if equilibrium shifts and you are greatly making your products and you have this copper bromide ion here, that would be green. So it would look like the test tube on the right. So let's assume we're in equilibrium. And then it says here what happened to the concentration of each when KBr was added. So if you're adding KBr, you can look in the chemical reaction, see that there's no potassium anywhere. So potassium on its own does not influence this reaction, but the anion bromide is there. So if you're adding bromide, that means you're adding a reactant. You're increasing the concentration of a reactant here. And in the balance of this universe, you have to undo that stress. You have to find a way to get rid of that bromine. So that means you're shifting it in a certain direction. That certain direction will either be blue if we are shifting to the left, or green if you're shifting to the right. You should pause, write down your answers to these. I'm going to go ahead and explain the answer, or you can look on the slide as well. But if we're adding our bromine, that means that we would be shifting to the right. You're consuming that extra bromide ion. You'll be making more of your products, and the products in this case would be green. This is a green color. So it would look like the vial on the right. Then, would it feel hot or cold? Well, that has to do with heat. Is a reactant in this case. The forward reaction is endothermic. So if our equilibrium is shifting towards the right, if we are making this product that is green and we are using up our bromine, that means you're also needing some heat in order for this to happen. So your reaction is taking in the heat from the surroundings. So if you're touching this test tube, it's taking the heat from your hands and all the other surroundings. So it should feel cold. Hopefully that makes some sense. Onto the experiment. So the experiment is going to depend, once again, on your name, your first name. So there are 2 different systems for 2 different sets of individuals. So what I'm going to do is I'm going to start with a third set. Nitrogen dioxide, I'm going to explain the entire lab, what your data table should look like. I even have an example all written out of what it should look like, starting with the name of the equilibrium system. So I'm going to be doing nitrogen dioxide. I'm also going to be writing this chemical equation that is up at the top. So let's take a look at this. We have one reactant, NO2. It's brown in color. So I would include this as well. I'd write that out. It's in equilibrium with N2O4. which is a colorless gas. And heat is written here as a product. That means that the forward reaction is exothermic. And we have some stresses. So as of right now, I would write down the name of the equilibrium system. That is the nitrogen dioxide system. And I'd write down the chemical reaction. Then for observations, you are just writing down what the stress is and what you see. So let's start with adding some heat. So if we see that heat here is a product, if we add heat, we're going to want to get rid of that. Equilibrium is going to want to shift, so we undo that stress. So equilibrium should shift towards this NO2 side. And it says it's brown. So if we add heat, we should see that this test tube gets more brown. And we do. It is a more brown color. So let's go back. What has happened is equilibrium has shifted left with the increase of heat. We have less of our colorless gas and we have more of the brown gas. So overall, it makes sense that our test tube looks more brown. So right there, I was explaining what happened chemically, that whole shift and why it looks more brown. That is in that third box. What do you think happened chemically? Observations are just stress is adding heat. Observations that it looks more brown. That's it. So let's think about what would happen with our next stress. Adding ice, which the stress means that we are taking away heat, we're reducing heat. So for this one, it makes sense if we reduce heat, we have less of it. Equilibrium is going to want to fix that by making more heat. We're going to go towards the right. We're going to make more of our colorless gas and less of that brown gas. That brown gas is going to be consumed. So let's see what happens. It looks more clear. It's gone from a darker brown to a lighter brown. Right, so that is it for this specific system, my example system. Now we're going to go back and for students with names that start with A through H, you're with me here in this cobalt system. J through Z, you can skip ahead until I do the iron thiocyanate system for you. So cobalt system first, A through H. You can see that we have more options than the two. So you're going to want to write down, copy paste this chemical reaction here. So we have a cobalt chloride that is a blue color reacting with water in the forward reaction to make cobalt water complex. So all you need to know is this thing here is red. It's an ion and it's a red in color. You also get chloride ions and heat. So that forward reaction is exothermic. So this blue and the red are very important. That color change is going to tell you where equilibrium shifted. So I'm not going to walk you through the answers here. This is for you to look through each of these stresses and then write down your observations and then write down why they happen. So let me add heat. Take a look at your chemical reaction, find out where heat is. If I add heat, where is it going to go? And then what color should it be? So for people that are colorblind, we went from a purple color to a blue color. Next, I'm going to add ice. You do not have to do these two, but if you want to choose to do ice, that means we're removing heat. It looks more red. I'm going to add water, so increasing the concentration of water. It looks more red. I'm going to add potassium chloride, which means I'm adding chloride ions. It looks more blue. Now I'm adding silver nitrate. If you look at the chemical reaction, you might say nothing's going to happen because I don't have silver and I don't have nitrate. But if we do that, you can see it gets red and there's a white precipitate, a white solid has formed. And that's because down here, we have a note, silver ions react with chloride ions to form the insoluble compound silver chloride. So silver ions, which we're introducing with our silver nitrate, react with chloride ions, and that is in our chemical reaction. If we're consuming chloride ions, that means you're reducing that concentration, you have less of them. So your balance of the universe is off, You want to get back to equilibrium, you need to make more of your fluoride ions. You do not have to do that one. It's a little bit more of an explanation, but you only have to do 3 stresses. So you can do any combination of the 4, or if you want to get adventurous, silver nitrate. That is it for this system. Iron thiocyanate. Here we have a chemical reaction. It has, in the forward direction, iron plus 3 ion, so an iron with a plus 3 charge. It is a pale yellow color. That reacts with a thiocyanate ion in the forward direction to give you an iron thiocyanate ion. It is a red color. That's the important thing. This ion is red and it releases heat. That forward reaction is exothermic. Heat is written as a product. So you are going to want that in your first box for your system. And we have some options here. I'm going to start by adding potassium thiocyanate. Potassium is not in our chemical reaction, but thiocyanate is. So I'm increasing that concentration. You should look to see if it's going to shift left or right to undo that. And then look at what the color is on that side of the chemical equation. If you're going left, it should be pale yellow. If you're going right, it should be red. So let's add the potassium thiocyanate. It becomes red. I am not going to be the one that explains why. You're going to be doing that yourself. Iron 3 nitrate. Iron 3 nitrate because there's 3 nitrates right here. Nitrates are not in here, but iron 3 is. We're going to add more of that. It becomes red. Now I'm going to add some heat with our Bunsen burner. It becomes yellow, a pale yellow. And then last, sodium, and you can see neither sodium or HPO4 is in this chemical reaction, but HPO42 minus, it's an ion. It's going to form a complex with the iron plus 3 ion. What that means, it's making bonds with iron plus 3. So you're reducing your iron plus 3 concentration. So if we add this, we're removing iron plus 3. And it becomes pale yellow. So that is it for this system. There is one post-lab question, so 2-parter, to explain what happens with carbon monoxide poisoning and your hemoglobin. It's on the last slide there. So all you're doing in this lab is your data table where you're explaining what 3 stresses you did, what your observations were, the color change, precipitate, whatever happened there, and why those 3 changes happened. So the example is already written for you. I walked you through this right here, and this lab is really nice at the end of chemistry because you can see the changes happen. You get to see the results of your changes and can come up with your answer based on what you see. So that's really nice. So that's it. I hope you enjoyed this lab.